Hey stats class, let's look at an example of how to find the least squares line with, so I'm going to click on the data option. I'm going to copy this, paste it into a spreadsheet, and then once I have it pasted, it wants me to make a scatter plot. So I'm going to click column A, drag to column B, insert a chart. Alright, so there is my data set, and you can see we have that value that's way up beyond all the rest of them. Right, 11 and 13. So I scroll back up. This data point right here, the fourth data point, you can see the x coordinates 11, the y coordinates 13, and none of the other values are in that ballpark. So if you recall the quartiles, I'm going to do the quartiles for the y's. I'm going to do the first and third quartile. So there are those values, and you don't have to do this. I'm just showing you that there's an outlier here. So this is IQR. And then if I start with Q3 and add 1.5 IQRs, you can see I get to 10.99 is the upper fence for the Y's, and I have a 13. So this is most definitely an outlier in the Y direction. So if I looked at the scatter plot and saw this, the first thing I would assume is that I made a mistake, and I'd go back and check my data to see, is this actually a 13, or was I typing too fast and missed a number? But once I've confirmed that it is an outlier, I'm going to proceed. I'll show you what happens here. All right, now we're going to find the equation of the regression line. So we saw this before in a previous video. I'm going to delete all this. That was just to show you that that is an outlier. But I'm going to put in this cell right below my image, I'm going to do equals line line est. So this is the best fit line. Just put your y's in first. Don't put any headers in there. You can't click the column at the top anymore. You just have to select your data, comma, select your x data. All right, make sure you're stopping at the last cell. It'll also give you an error if you go beyond your data. All right, 1 for calculate y-intercept, 0 for verbose. We don't want those other stats. So this is my slope. It's always return slope first, y-intercept second. All right, it wants the slope to 3 decimal places, y-intercept to 2 decimal places. Make sure you're paying attention to that. So slope to 3, y-intercept. All right, notice it's also the number with the x is the slope. The number without the x is the y-intercept. So they're reversing it from the way that this is giving it to us. So 3.53 goes first. All right, so do make sure that you are getting those the order down. 3.53, the y-intercept was first there. The slope was second. But remember, the slope is with the x. All right, now if I use this line, it's determined by the value of the correlation coefficient. So if I did, I'm going to put R right there below it. If I did equals correlation, and I selected my y's, comma, my x's for correlation. So there's the correlation that I get. And depending on results of a correlation test, because that's not extremely strong correlation, but I may or may not use a line to estimate this with this many data points. The critical values for this one is, these are the critical values that I have to get beyond. So for 0.1, it's 0.521. We would definitely clear that. 0.05, barely clear that, but 0.01, like we wouldn't say that there's regression here because we're not beyond that number. So depending on your value for alpha, you may or may not even say that this line is suitable for prediction because of that R not being substantially large, like really close to 1. But the problem is that outlier. So what is it saying? There's no trend in the data. There's a influential point that strongly affects the graph of the regression line. That's the problem here. Let me show you why that is. So that's all I asked there, but it doesn't get into the why. But the problem is this one point, if I were to remove it, delete cells and shift up, now that point's gone, and look how strong the correlation is now. It's virtually 1. There's no way we wouldn't reject the null hypothesis that rho is equal to 0 with correlation that strong. So for all of them, for 0.1, for 0.05, for 0.01, with the sample size that we have, we would reject this and say that there is, based on this, there is definitely correlation in the population. That outlier, that linear pattern is very strong once we remove that one single outlier that was way up here away from all the rest of them. So outliers in regression dramatically alter the correlation coefficient, and can take things that have very strong patterns like this, like 0.98 virtually, and make them point in the 0.6 range with just one data point that's kind of out of place. So what we do in cases like that, if we're just seeing one outlier and it's throwing things off, throwing predictions off, we tend to remove that outlier because it'll make based on the rest of the data, we have a very strong trend, and we can use that better line to make predictions if it just removing a single value like that. So that's the idea here. They don't go into it. It doesn't get in depth enough with the questions that they ask. But that's what's going on with a question like this and why it's even asked. It's just to show you the power of an outlier with regression.